Hey guys, this is Garrett Wong, also known as Ensign Harry Kim from Star Trek Voyager, and you're watching Astronomy Live.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Stop.
Alright folks, welcome to Astronomy Live. Tonight we're going to be trying to track the return of OSIRIS-REx. I'm starting a little early here because I was able to set up the telescope here in Florida, but I'm on the struggle bus when it comes to weather and trying to actually see OSIRIS-REx through said weather. We've got intermittent clouds. It's very soupy tonight. We do see some stars through the clouds, obviously, but so far I haven't been able to see it distinctively in the images. But I'm going to continue trying to process the images as I get them here. And I also have a telescope scheduled to take pictures from Chile in 20 minutes or so at 4 a.m. Eastern Time. It should fire up and start taking pictures. And it looks beautiful in Chile right now, so I'm confident that all else fails, we will get pictures from Chile. But I'd like to get them from my own telescope as well, if possible. And a lot of that's going to come down to whether the weather cooperates enough or not. OSIRIS-REx is fairly dim, so it's a bit of a tricky target. But I'm doing direct tracking right now with NeoTracker, which I need to update anyway. My real-time JPL Horizons technique is cute, but the problem is it's commanding in altitude azimuth coordinates right now, which is all wrong. I should set that to equatorial because I'm polar aligned right now, and the telescope won't accept altitude azimuth commands, so I have to use the old feature of the downloadable orbital elements file. The problem with that is that's a two-body approximation of the orbit, which is no longer valid. As it's approaching Earth, Earth's gravity is perturbing the orbit significantly over time, and so where it's predicting it to be isn't quite where it is, and it's not moving in quite the way. The telescope's not direct tracking in quite the way the spacecraft is really moving, so that's a problem. Alignment. I'm going to do a max stack, so I'm going to stack the direct tracking pictures here real quick. See if there's anything there. Yeah, I'm not really seeing it. Okay, I'm going to stop direct tracking now. And we'll go back to guided exposures. I tried that at the beginning of the evening, but there were some intermittent clouds, as I said, and it left a bit to be desired. I mean, that could be, okay, you know what, forget what I just said. Let's resume direct tracking. Forget what I said. I'm wondering if that's good old OSIRIS-REx here. It's possible. Okay, so let me do a little magic and Pixin sight here real quick with the contrast. And let's see what I can show you guys. It's not readily visible in the individual exposures, and this is similar actually to what I saw in 2017 during the Earth flyby. Didn't really see it in individual exposures easily, but by doing direct tracking with Neo Tracker like this and stacking the pictures, I was able to get something out of it. So let's see what it looks like when I adjust the curves and Pixin sight. Do a little dynamic background subtraction for funsies. Listen to the raccoons in the background. At least I assume that's a raccoon. Okay. Yeah, that's questionable. It's where I expect it to be in the image, but it's not. Signal to noise ratio is terrible, if that's what it is. Yeah, that's ambiguous at best. Alright, we'll forget direct tracking for the moment. We still got 15 minutes till we get it with iTelescope, so let me see what I can do now with... Oof. Man alive, that vignetting could actually be a sign of really bad cloud cover. Yeah, old Jupiter's got a bit of a halo to it, which isn't good. Alright, so... Whew. One way or the other, we'll get it. We'll get it with iTelescope. No doubt. We got a beast of a telescope that's going to fire up for us in 15. And I'll download those images in real time and show them to you as we get them. So worst comes to worst, we will, knock on wood, we'll see it. We've got a 20-inch telescope coming up here pretty soon. So I'm going to get that window open and just be ready to start taking a look at those images. In the meantime, what I will do is I'm going to go back to the images I took earlier before I started up the webcast. And that was before I was doing direct tracking and before the weather was frankly this bad. Yeah, based on what I'm seeing with the haze, we're not going to have much success from Florida at the moment. I mean, we're trying to look at something that is almost magnitude 16, magnitude 15.8 right now. That is very dim, and that's the whole OSIRIS-REx spacecraft. So, I've been yammering about the telescope, but I haven't even really talked about the mission to you guys much yet. But OSIRIS-REx is returning with a sample capsule from the asteroid Bennu. So it launched out to Bennu, and a few years ago it grabbed a sample off the asteroid and is returning now to Earth. The main body of the spacecraft will fly by Earth, but it's currently aiming for Earth, and 4 hours before re-entry will detach a small return capsule that has a heat shield on it, and inside that capsule is the sample that the arm from this robotic spacecraft hit the asteroid with. Essentially, it came down gently and blasted the asteroid with some compressed air, something, or compressed nitrogen, something like that, and basically sent shrapnel everywhere off the surface of this loose sort of conglomerate of debris of an asteroid, and collected a whole bunch of sample, put it in the return capsule, and it will be returning to Earth here today, and it should be landing in the desert in, I think, Arizona? Something like that. I think it's in Arizona. I want to say Arizona. But somewhere out west. It's going to be landing down. And so in 2017, when it swung by Earth for a gravity assist, I caught an image of it with this telescope and also with the iTelescope network. And it is not bright. And so somebody was asking, November 939 November was asking earlier, how can I see it from home? Is there any way to know its position in the sky? You can get the position in the sky from JPL Horizons. So I'll link that in the chat so people can see if they want to go get ephemeris for their own home location. But this sucker is dim. Very, very dim. Very, very tricky target, and you need pristine weather, which I don't have at the moment here, to really be able to do it. So I'm gonna astrometrically solve some of the earlier pictures if I can. Out of curiosity, is there anything even available in the autoguider? Survey says no. Okay, that's not terribly surprising. Alright, I'm going to focus now on trying to get these going. You know, it really fools me looking at the time lapse of the tracking on the stars with the autoguider. For a moment, I think I'm seeing something in that time lapse moving, which would be the spacecraft, because I'm tracking the stars. But first of all, it would never come through on streaming compression. It's just not bright enough. And secondly, I'm not sure if I'm fooling myself. So the way to not fool myself is to astrometrically solve these pictures and then align them based on the coordinates of the pictures and the expected coordinates of the spacecraft. And I do have a program I've written to do just that. But the first step is to astrometrically solve the pictures. There's 15 frames I've got there. And so I'm going to go inside and astrometrically solve those pictures real quick, and I'll be right back, and we'll stack them and see what we get. And then when I get back, we'll also start taking a look at the pictures coming in from Chile. So be right back. Alright, so I had a little trouble with the desktop. I'll have to fix it later. Trying to get the astrometry is not feasible at the moment, but I'm getting it off the website instead. So I have to do it one by one, which is slow, painful, all the rest, but I've got a few images at least. So I'm going to see if I can do this with those. My objective is to try to use a program I've got to automatically align them based on the orbit of the spacecraft. So in the meantime, my telescope is fired up in Chile. It's currently focusing, and we'll be taking images soon. Okay, so oh, I have to give it the elements file. Okay, that's fine. That's perfectly fine. So I have to give it, okay. Oh, really? It didn't work. Why didn't it work? Maybe it doesn't like the elements file? It ought to. What's your big problem? Is it looking for the wrong type of file? Oh yeah, it's looking for the wrong type of file. Okay, that's fine. I'll fix that real quick. Whoa. Okay. Doesn't like that either. Getting a little error with my stacker. I'm not sure why. Operands could not be broadcast together with the remapped shapes. It's remapping the shape wrong. Why is it doing that? Yeah, okay, what line is that? It's padding. 206. I don't need the version of the program that is supposed to handle color images anyway. I wonder if that's what's causing it. There we go. Okay. Good, 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 good. I got it to work, in theory. Now, I've only got, like, 6 images here, so this may not be enough. Stacking to get the job done. I don't know. Yeah, it's pretty inconclusive at the moment. I mean, there's maybe something there, but I need to stack more frames. Which I do have more frames, but... Alright, let's take a look at the pictures from... from Chile. Ah, we've got a beautiful target. Alright, that's what I'm talking about. Nice! Okay, so... what's the best way to do this? Oh, a little transmission error there. That's fine. I know. We'll just go to data.itelescope. Okay, I'm going to download my... Nope, that's not the... how do I get my data? They changed the website. Links. Download my data. There we go. Okay, this is T72, I think. Yeah, this is T72. Alright, let's get some data. Download. Okay, so we're downloading some images, fresh images from Chile right now, and based on just the preview JPEG I was looking at, oh yeah, we got the target, no question. Well, now let's use a bigger scope and a cleaner air with with no problems with the weather. Right? Okay, let's see. Oh yeah. Okay, cool. Let me share the video. So I've already got a time lapse of 3 frames. They're 1 minute apiece. And I might slow down the motion of the time lapse here. Let me do that real quick. So it's not quite so fast. Right now it's 10 frames a second. I'm going to cut that in half down to 5 frames a second. Okay, let's get going here on this. I don't like Windows, hello Windows. Don't do this to me, Windows. Whoa. No, don't. Don't close OBS Studio. I would not like that. Okay. OSIRIS-REx. Later I'll keep working on trying to process my own images here from Florida and see if I can pull anything out of what we had there, but that's okay. For now, we do have current images of OSIRIS-REx from Chile. How about that? How about that? That's not bad, huh? So that streak moving out from the bottom towards the top, that is our boy. That is OSIRIS-REx. Now, the capsule hasn't released yet off the spacecraft, so they should still be integrated until 4 hours before entry, so that's not for several more hours, so I won't see that happen. So they should still be on course to reach Earth together, and then after the sample canister comes off, I believe the spacecraft, I haven't really looked into the details, but I'm pretty sure the spacecraft's going to do a divert maneuver, and I believe it's going out to asteroid Apophis next. Alright, I'm pretty happy about that. That's looking pretty good there. So as these pictures keep coming in, I'm going to keep adding them to the stack. Just gotta take a look at the preview JPEG out on the website. It's pretty slow to load, but it's there. Okay, that's looking pretty good. So yeah, free plug here for iTelescope. Really good service to have, because when you get in a pinch like this and the weather's not cooperating and you got a transient event that you only get one shot at, it's good to have coverage in more than one location. It's good to have telescopes in multiple locations around the world that you can call upon to get your target, and that's what I've done here. So yeah, I'm still looking at the sky, and Jupiter is almost directly above, and you can tell how badly hazy it is just by the halo around Jupiter. It's really smeared the light from Jupiter out all over the sky, so I really don't see any stars in the direction the telescope's pointing right now. That's why I'm not able to pick it up at this point. Whether I was able to get any of it earlier, I don't know, from Florida. But regardless, we've got a telescope firing up in Chile right now that's getting the job done. I love it. I love to see it. Now I've got 40 images scheduled with this telescope, which is honestly going to cost a pretty penny. This is not a cheap telescope to run at all. I think this one, I don't want to misquote it. Let's see. T72 hourly rates are, yeah, $149 an hour on the cheapest monthly plan, which is what I'm on. So almost $150 an hour to run this, and I've got it for almost the full hour, so you do the math. But worth every penny. The minutes you get on this membership every month do roll over indefinitely, so I've got the time banked. It's not like I'm opening up the old wallet on this one. It's all banked for me, but I definitely used up a significant portion of my saved minutes on these telescopes for Artemis 1. And my account still hasn't recovered from that. So this is now going to be a significant impact, but that's fine. That's worth it. This is what it's for. This is the whole reason I have this account on iTelescope is for events like this. And it's good to see that we're getting good images here. Not sure why it... Huh. I'm just looking at the console log, and it looks like it repeats the number of image I'm on twice? Once at the beginning, once at the end? Or no, just twice at the beginning, within seconds of each other. That's weird. I'm not sure why it's double printing the index number of the image it's taking. I'm just not used to that behavior. Anyway, neither here nor there. I just want to make sure it's not goofing anything up, but it doesn't seem like it is. Alright, let me see if there's any more images available. Yeah, we got 3 more images to download. That's good. Okay, I'm going to move that into the T72 folder. Extract here. Let's see if it extends the time lapse if I just run the program. It should update the video file. Oops, I didn't mean to close Genie. Come back, Genie. Yeah, I did a little something goofy there. Let me... try to run that one more time. I accidentally closed Genie while it was running. That might not have helped anything. Okay, that looks good. That looks good. Okay. Oh, it looks like it paused the video. It probably didn't like being accessed while it's also being updated. There we go. Alright, let me see if there's any more images available yet. Not yet. It's pretty slow to upload my frames as I take them. Oh, here's another one. Okay, good. Just gonna download another frame. Just gonna keep downloading them as they come in. Probably have to reset the video after it's done processing the new frame. Okay. So that's updated. Oh good, we got a whole bunch of new frames here. Frames 8, 9, and 10. Downloading those now. There we go. Okay, seems like it's actually auto-updating, which is nice. yeah, the touchdown time are we now? So we're at 4:27 right now. Touchdown, I think, is at 14:55 Universal Time, 10:55 Eastern Time, so about 6.5 at this point hours. Let's see how good I did on anticipating where it would be in the frame, because I'm looking at a more recent image on JPEG, but I'm downloading the raw FITS files, and that's what you guys are seeing, the processed FITS files, which take a few more minutes to get uploaded from the telescope and then downloaded to my computer. Looks like I did a really good job, actually, anticipating how long it would take to cross the field of view based on how fast NASA was saying it was going to be moving. So I've got a total of 40 images scheduled on iTelescope. It's almost done with the first set of 20, and then it's going to move the telescope's position ahead to where it will be where the spacecraft is anticipated to cross the center of the field of view at 45 minutes after the hour, and it'll finish up the last 20 images in that position. So that's good. One more frame is ready. Okay, there's another frame in there now. You can see it's crossed through the middle of the frame at this point. I'm actually clipping, it's currently cropping the top and bottom of the frame a bit because it's actually kind of a square aspect ratio, and I'm stretching it to fit, well, I'm scaling it so that the width of the field of view fills the 16:9 frame for YouTube, but probably going to have to scale it back down at some point as it gets higher up the field of view. Is there a live tracker for this probe anywhere? Kind of a satellite tracker, real-time stats? So closest I can recommend would be JPL Horizons, but it's probably not what you're looking for. You're thinking, probably you're looking for something with just facts and figures like current velocity, current distance from Earth. You can get those numbers out of JPL Horizons, but it's kind of dry, I guess you could say. It's like getting a spreadsheet. You just get a table of either position or orbital elements. So you can get all the information you need to do the tracking, which is what I did to set this up. But that's probably not quite what you're looking for. Like Intuyo is not going to have it. YO is not going to probably have this in any accurate fashion. Their site is designed for Earth orbiting satellites. This vehicle is hyperbolic relative to Earth. It's in a solar orbit being perturbed by Earth currently as it flies by. Well, the main body of the spacecraft is going to fly by. The capsule sure isn't. So you have to be using some sort of software that's going to account for the gravity of the Earth as well as the gravity of the Sun and the fact that it's a hyperbolic trajectory. Most satellite tracking programs are not designed to do that out of the gate. Satellite tracking programs that rely on two-line element files cannot ingest the elements of this satellite. Two-line elements or three-line elements, the TLE files, by the nature of the format, requires the satellite to have an eccentricity less than 1 relative to Earth, which does not hold true for this vehicle. So you can't even describe the orbit in a way that is compatible with the file format needed for most satellite tracking programs. Which is why I developed NeoTracker separately from SatTracker to be able to do this kind of thing. Yeah, the main spacecraft is going to do a flyby. It is dropping off a sample return capsule that will actually re-enter Earth. So it's part of it's going to hit Earth by design and re-enter over the desert out west, I think over Arizona. Let's see, let me pull up the actual landing site. And so that's going to be picked up off the desert floor. Utah. Okay, so it's coming out over Utah. So it's landing Great Salt Lake Desert. And it's going to hit the Utah Test and Training Range. Blah, blah, blah. So hopefully everything goes okay with that. So this is bringing back a sample from asteroid Bennu. But the main body of the spacecraft with all the cameras and fun stuff is going to fly by Earth to go out to a new target. So yeah, it's going to divert the main body is going to divert and go on to intercept asteroid Apophis. And Apophis is supposed to be coming around in 2029. And that's the one that they weren't sure at first if it was going to even hit Earth. And in fact, there's this very small chance that Bennu could hit Earth in over 100 years. Alright, so now we got more frames to download, which is good. I'm going to work on that. Welcome, Rusty. Glad you could join us from the great down under. It's got frame 13, downloading 14. So we're downloading images from a telescope that's in Chile right now that I've got fired up, taking pictures of OSIRIS-REx as it approaches. Ultimately, the weather in Florida here decided not to cooperate very well. But that's okay. I had a backup plan. Let me see what the telescope is doing live. Let me check on it. It's in the new position now. So I should be seeing OSIRIS-REx at the bottom of the frame again. It's kind of already at the midpoint, but that's okay. So the last few frames might not have it in the frame, but we'll get plenty of frames with it nevertheless. So you can see the time lapse is now extended. We're through frame 16, I believe. Yep, frame 16 of 40 total that I've got scheduled. And so far the telescope has taken about 20-something, 28 images now. But it takes a few minutes to get them downloaded. Well, first I gotta upload the raw data from the telescope, and then I download that. Okay, so now the last of the frames from the first telescope position are available for download through frame 20. So I'm going to finish downloading those. And I think we may even have some of the frames from the new telescope position. So the telescope repositioned itself to catch OSIRIS-REx again, because as you can see, it's headed for the top of the image. cool. I timed that one. That first position timed out perfectly. So you can see it's flying off the top there a little bit. I can scooch this down because actually there's more frame here than I can even fit on screen. That's perfect right there. How about that? That's cool, huh? Alright. So we got the first 2 frames of the new telescope position ready for download. So I'm going to start working on that. And ultimately we'll have 2 time lapses side by side, I think. So I'll have a separate time lapse for the new position. Unless I just throw it into this one, I guess, but that's kind of jarring. So I think I'll keep it as a separate time lapse for the moment. Okay, we got 3rd frame from position 2 now available. So I'm going to download that and get this going as a second time lapse, and we'll load them up side by side. Okay, let me get this loaded up. Okay, so on the left we've got the original, or the first time-lapse based on the first position, and now on the right we have a new time-lapse forming. You can see at the bottom right there a streak of OSIRIS-REx still moving. So we could do it like that, or I could just make the new time-lapse the only one I'm showing. It's up to you guys, whichever you prefer. Okay, updating the new time-lapse here with a few more frames. So we're up to frame 8 now on that time-lapse, as soon as this is done processing. That's better. And maybe at this point there's enough frames in the new position to make it less jarring if I just put them all in one directory and yeah. I'm just gonna make this time-lapse the time-lapse. Okay, so what I'm gonna do is okay, so I'm just going to update this time-lapse with the frames from both position 1 and position 2. So the stars will suddenly shift when it goes to position 2, but I think that'll be fine. I don't think that'll be too jarring at this point. It's just got to stay on position 2 long enough that it doesn't flip right back to position 1 and kind of get you disoriented. but I think that'll be fine. It'll be less confusing for new people joining anyway. They're not seeing two streaks going, wondering if I'm showing the capsule and the spacecraft when they haven't separated yet. Okay. Okay, I think that's good. I think that's fine. But you guys let me know if you don't like it. How much time do I have left? So my the telescope actually just finished up taking pictures, but it's now still uploading the last 10 minutes worth of light. The last 10-11 pictures or so are still being uploaded from the telescope, and then I can download them. So probably about 10 more minutes, roughly. Maybe a little more depending on upload time for me to be able to get it downloaded. But I'll have a whole video separate from this, a summary video, where I analyze these images, solve the orbit, do all that fun stuff. So we'll have plenty of data here. Updating the time lapse again. Tiny flashing dots, satellites, or just stars twinkling, or noise. So the little flashing dots are just noise. There's cosmic ray strikes. Those are the little flashes that occur in single frames. It's actually radiation from space, basically, hitting the CCD and inducing a charge. And one of the ways you can tell it's not a star or any real light source entering the telescope is it doesn't form a point spread function. So if you look at the stars, they're slightly soft edges. They're kind of white blobs with some taper to the brightness at the edges. The hot pixels are stationary. They don't even move with the slight bit of drifting of the telescope. You can see the stars actually do move at each position a little bit. They drift a little bit over time. The hot pixels are little points that don't, and the cosmic ray strikes, like the hot pixels, they don't form point spread functions. They're just sharp little individual pixels or streaks of radiation on the CCD. So those are cosmic rays, and that's noise. You can also see that the hot pixels don't change between position 1 and position 2. You can see all the stars change. The pattern of stars changes as the telescope moves to catch up to OSIRIS-REx, but the hot pixels remain fixed at both positions. Now, these frames have been calibrated with dark frame subtraction, but it's not perfect, and there are still some hot pixels that were not in the dark frame reference files, apparently. Yeah, unfortunately I won't be able to record the separation event. That will be after I'm able to see it from Chile. In fact, Chile's already done. They're already starting to hit twilight down there. If not now, then in a minute or two. And so, basically, there's no way for me to see the separation event occur from a telescope on the ground. Let's see if the last images are available yet. Not yet. Yeah, cosmic rays will induce a charge when they collide with the CCD, so that's why they show up. It's not like light. It's not being focused by the optics, and it's not subject to diffraction, so you don't get a point spread function like you do with light entering the telescope. You just get this sharp, either it's there or it's not, of charge built up in the pixel wells from the radiation striking the CCD. one more frame came in. Gonna add that to the time lapse here. The velocity. So they're aiming for 12 kilometers per second at re-entry of the capsule. Obviously, it's building in velocity to that point as it accelerates under the gravity of Earth. So that's not the velocity it has right now at the moment, but that's the peak velocity, essentially, that it's going to have when that sample return capsule hits the atmosphere. Seems like the update is 12.9 kilometers a second. I don't know, I'm getting a slight variation in that number depending on what the source is. But somewhere in that ballpark anyway. images. Nope, still waiting. In the meantime, I'm doing some additional processing and astrometric solving of the pictures I was able to get from Florida before everything turned to garbage on weather, just to see if I was able to pick anything up with my own scope. Still waiting on the last pictures to upload from the telescope in Chile. see if we got any more pictures. Wow, it's really not. Let me try refreshing altogether. Still waiting. Okay. Well, so be it. Make sure that it didn't terminate the reservation early or anything. Guess I need to go check the run log. Says it launched the plan, but I don't see the run log. I'm not sure why it's stopping at frame 14. I thought for sure it finished out the run, but I'm not seeing. I'm not seeing the new frames. It's bizarre. Okay. That's 9th. Okay. Yeah. Okay. Yep. Wow. Alright, so I was fooling around with my pictures from here from Florida, and there was like 1 to 2 minutes, where the sky was just clear enough I could start to see more stars in the picture. So I pulled up the astrometry on it, and then loaded in the coordinates that OSIRIS-REx had been at that time, and I can see the streak. It's there. Faint as a bugger, but it's there. Alright, I'm going to try... What I'm going to do is I'm going to load up the coordinates at the start and end of exposure and overlay that as a line on the picture. least I'm pretty sure it's there. Let's see if I still think that after I overlay the line on it. Oh, maybe not. Maybe I'm imagining things. It's hard to say what's camera noise, what's real, but when it's only one frame, it's pretty iffy. This was a 60-second exposure, right? Yeah, 60 seconds. Okay. Okay, that was that. That was that. Yeah, okay, so the predicted streak is not as long as what I'm thinking. It's also not quite where I'm seeing it in the image, I thought. Here, I'll share my screen. Or I'll share that window. Just so I can show you guys what I'm talking about. Okay, so didn't mean to do that to it, but I don't know if you can see my cursor, but up in the top right there's a little box moving around where my cursor is. So you can see the green arrow, that's the direction and length it was supposed to be traveling according to JPL, and there's this little streak of a few brighter pixels just to the right of that. That made me think that was OSIRIS-REx maybe streaking in that exposure. But it's not a perfect match for the position, so I'm not convinced to say that that is exactly where OSIRIS-REx was supposed to be. Yeah, it's possible, but I'm not sure. I'll see how well the astrometry matches in the pictures from Chile, and maybe even use the orbit solution to predict where it should be in my picture from Florida and see if it's a match. It's close, it's tantalizing close, but it's iffy. If I saw that thing moving in multiple frames, then I'd be more convinced, but the problem is there was only like 1 to 2 minutes where that was even visible, whatever that is, and whether that's because it was noise or because the weather just was not good, I can't tell. But I was looking at the individual frames, and there are other stars in the picture that only become visible for a couple of minutes and then never to be seen again. And in the best of those frames, that's where I'm seeing this. And it made me think, oh, that's OSIRIS, because that's about where it was supposed to be in the picture. Yeah, but that could just be random noise that just happens to be very close to where OSIRIS was supposed to be. And the problem is that's the only... Gosh, yeah, that's the only moment of time where I can see anything there. But looking at the other stars, like, that's also where they're the brightest. That one frame has the stars at their brightest, meaning the clouds were at their thinnest in that moment. So it's possible, but if I blink the previous frame, it kind of looks like it's streaking from further up and to the left, maybe, but man, you really got to be pixel hunting at that point. And then by the next minute, it's gone. Well, it's clouded at that point. So, oh well, that's as good as I could do. If the weather had been good, I'm convinced it would have been more feasible. It would have been a lot better to be able to get it from Florida if the weather had been good. Oh well, let me see if those last pictures came in from Chile or not. If not, I'll just tear down and we'll take a look at them in the follow-up video when I do the analysis of all this data. Yeah, I don't see anything there. That's weird. And I haven't received the receipt yet for my telescope telling me how much I owe them. And that would have a summary of all the pictures that were taken. So for some reason I can't find the run log, I can't find the receipt, and it's stopping delivery on the 14th frame of the second position. Yeah, I don't have any more frames from Chile. That's weird. Not sure if maybe I ran out of time? Oh, that's what happened. Yes, there were only 14 pictures because I ran out of time. I forgot my reservation ended at 55 after the hour, not 5 a.m. or 6 a.m. Chile time. So, yeah, I was at 54.8 sec. Well, what was I at? No, these are 47, 48. No, it's 48.29. I should have had another minute or two. But I think it actually ended at 50? Maybe I ended at 50 because I had to be done by 50 because you couldn't... Yeah, I think maybe I couldn't stretch the reservation to 55. So it might have looked at that and said, oh, you've got a minute and a half to run one more minute long exposure. We're going to cut you off there. I think that's what happened. I think I just ran out of time on the reservation. So 14 images was all I was able to get from that second position. And that's fine. So that actually is the completed time lapse and has been. So, yeah. Well, we've definitely got it from Chile, no doubt about it. The only question is there something there from Florida? Maybe. But I'll run the analysis and see. The real key is going to be to see just how close the prediction is from JPL to the actual images we have from Chile. And we can do that right now before I close out the stream. I can upload one of these pictures from Chile to Astronomy, and we can just see what the overlap is like. So let's get set up here for let's see, this picture was it 3:14? Okay, so that was a little bit before Chile fired up. So I'll take the first Chile picture as an example. And the trouble is, when you only have like one frame that's any good, and it's real marginal, when I say any good, it's like, yeah, you're down in the noise level, you can't stack anything, because all the rest of them are clouded out. So you have one frame that maybe has something. Now, of course, from Chile, we've got beautiful frames, and we've got tons of them, but this is also a 20-inch telescope that is just a monster. Okay, so I'm gonna load up an SAO, this first frame from Chile. And now I'm going to go to JPL Horizons and tell it, okay. Tell me what you predicted precisely for this time. And what is this precise time? This is display fits header. This was 4:04 a.m. Eastern Time in 25.47 seconds. 8:04 Universal. Okay. Interesting. Jeranism level interesting here. So it looks like the JPL prediction is a few arc seconds off from what I'm actually observing. So, well, maybe not. Okay, actually that made my, well, a little bit, yeah. Okay, but it's mostly in timing. It's not in a lateral offset, it's just a timing issue, which could be down to the telescope camera clock not being super duper accurate, but it should be. But okay, it's pretty close. It's pretty close. So let me show you guys SAO Image DS9. So if I take the very first frame from our time lapse that we've been viewing, and I overlay a green line that represents where NASA JPL predicted OSIRIS-REx to be, you can see the direction, the length of it, that's all fine. It's just a little off, just a tiny amount. Mostly in timing, so it's predicted to be a little bit further down the image and just a smidge to the left, but pretty close. So that's not bad. That's pretty darn close. Obviously this is, you know, OSIRIS-REx, it's pretty much right where JPL said. It's mostly just a difference in timing by a matter of seconds, if that. And again, could that be due to the clock on the computer that was taking these pictures in Chile being a little bit off on its computer clock. Maybe it hasn't updated in a bit. It's possible. So I'd say that's it's a good indication that the Florida image we should be seeing, if we're able to see OSIRIS-REx, it would be pretty much where the marker is. It would be mostly overlapping with the marker, which is not really what I was seeing in that previous frame. If I go to previous frame, yeah, I thought I was seeing the streak more out here to the right of where the green marker is. So I'd say we don't have a good detection of it from Florida, but we obviously do from Chile. So I will do analysis on the images we got from Chile and solve for the orbit. Should be fun. And then I'll put together the final process time-lapse in a separate upload on this channel. Probably just be a YouTube short, because it's going to be pretty quick. Just cover the basics, what we saw here tonight, and the orbital solution from that. So that's going to do it for this stream. Thanks for watching, and if you have any more questions, I'll take them now as I wrap up. How close to the horizon is it? Well, for me, it's very close to the horizon at this point. It's already, too low to be able to get. And like I said, the weather here, not great, kind of murky, kind of hazy. Ahead of schedule by a second. And again, I can't tell if is that due to the computer clock in Chile? Maybe. I wouldn't put it past the realm of possibility that that's not real. That's not a real difference. It's just the computer clock in Chile may be a little behind. Hey, Wally. Yeah, I hope you're able to get it. Yeah, this is somewhat live. This is I've been showing a time lapse of the images I collected from, well, somewhat live. Now it's 45 minutes old, but basically the last image here was from 45 minutes ago, and it covers, well, 55 minutes ago, I guess, and it covers about 50 minutes of time. So this was a time lapse from 4 a.m. Eastern Time to 4:50 a.m. Eastern Time, or 8 to 8:50 UT. Some clouds at the moment. Well, hope you get better weather than I do from here in Florida. We didn't have very much luck from Florida. I aligned the telescope setup, did all the good stuff, and couldn't see it. Just couldn't see it. It was too murky. There was like maybe one frame that I thought I was getting something, but without more frames, it's impossible to say for sure, and I'm not convinced that I was. But there was only one frame where I could see more stars just from a temporary gap in the clouds. But it's been pretty crummy here, unfortunately. Clear sky clock was a little too optimistic this morning. Man, I'm seeing Venus, and it's just covered in haze. Alright, well that's going to do it for this stream, so thanks for watching. And until next time, clear skies.